All right, we're going to look at a few different things. It's going to be a kind of a hodgepodge of um, information and theorems about our right triangles. It is all about our right triangles, though, so there's a little bit of a common theme. So let's look at this first little area here. And this says that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and each other. Okay, what does that mean? Altitude, remember, excuse me, is a line that is drawn in our triangle that hits at one of the angles and it makes a 90 degree with one of the sides. Okay, so this is saying that if that altitude hits that hypotenuse, then this triangle formed is similar to this triangle formed, and those are both similar to the big triangle. Okay, so if we're trying to find x, we can do that by using our proportions knowledge, that's the word I'm looking for, that we have about similar triangles. Remember our similar triangles, we can put the side over the hypotenuse. So if we're looking at, let me get a different color, this triangle for x, then this is the side. And remember the hypotenuse is the one that's across from the right angle. So we've got x over 12. And let's go ahead and use the big triangle here for the other triangle we're comparing it to, because remember all three triangles are similar. So the side of our big triangle, and here's a right angle over the big triangle, so that 15 is the hypotenuse. And I can do my cross product, multiply, solve for x equals 7.2. What's important to remember here is when the line that's cutting our triangle hits that hypotenuse, all three triangles are similar, so you could use different information for each of these to find out what x is. Okay, let's go to the right. Geometric mean. This is, we need to know this before we get to these two down here. So this is just a little side note here. The geometric mean of two positive numbers, some number A and some number B, is the positive number x such that, such that A over x equals x over b. And A and b are our numbers, and the mean is our x. So this, when we do our cross product, would be x squared equals a times b. And how we would solve for x is we would take the square root of both sides. So x would equal the square root of a times b. So, well, I just threw that in. So if we're looking for the geometric mean between 6 and 30, I'm going to go through this whole process, but really you can jump to this process and take x equals the square root of 6 times 30, and then simplify your radical. But I'm going to go through the whole process. So 6 is going to be my a, 30 is going to be my b, so we've got 6 over x over 30. And when I do my cross product, that is x squared equals 6 times 30. And 6 times 30 is 180. X squared equals 180. I'm trying to solve for x now. So let me take the square root of both sides. X equals square root of 180. Remember, we're simplifying, not getting a decimal number. So our factors, move this up here. X is going to equal 2 times 2, 3 times 3 times 5. I'm going to pull out my pairs because we're talking about square roots here. So we got x equals 2 times 3 on the outside, 5 is left underneath. So the geometric mean of 6 and 30 is 6 square root of 5. Okay, so we need to know how to do that to do these. So the altitude theorem states that the length of the altitude, this line right here, is the geometric mean of the lengths of the two segments that it creates when it hits that hypotenuse. So my A and B here is 8 and 12. So, and when I do the geometric mean of that, that's going to give me that x, that's going to give me what that altitude is. So the reason why it might be helpful to put it in this form is maybe you have the value of x, you have the altitude, and you're trying to find one of these lengths. But this one is just a and b, so we can just say that x equals the square root of 8 times 12. 8 times 12 is 96. Okay, let's see what are the factors of 96. So, 2, 3, 4, 5, 3. Pulling out my pairs. We've got 2, 2, and then those are left inside. So x equals 4 square root of 6. All right. So like I said, on this one, you're going to be using this knowledge. You might be given this 8 and this maybe 10 or something, and then trying to find that. And so then you would set that up. Let's just do a little side example here. Say this was 10, then you would have 8 over 10 equals 10 over b that you're trying to find, cross multiply. Okay? And then that one's easy to solve. All right, leg theorem. The length of a leg is the geometric mean, so again, we're using this, of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to the leg. Okay, adjacent means next to. All right, so the length of the leg is the geometric mean of the lengths of the hypotenuse, the whole big hypotenuse, and the segment of the hypotenuse. You see how the altitude cuts the hypotenuse in two segments adjacent to the leg, next to the leg. So not 7, but this one that's right here. You can find that one. 12 minus 7 equals 5. So this one, because it's next to. So then here's another reason why you can set this up like this, because we're finding leg 5 over x equals x over 12. So we're doing the geometric mean between 5 and 12. So then this equals, when you do your cross product, what's 5 times 12 is 60. And then you need to take the square root. X equals, factors of 60 are 2 times 2 times 3 times 5. Pulling out my pairs, no more pairs. So x equals 2 square root of 15. And that is your leg. All right, let me know if you have any questions.